Okay. So if 20 grams of iron reacts with 20 grams of oxygen, how much iron oxide is formed? What is the limiting reagent? What is the percent yield if 26.73 grams of iron oxide is formed? All right, I'll give you some guys time to work on that. That's our starting problem. All right, so let's go over this. So you start with 20 grams. Iron. And then use the molecular weight of iron, which I'm going to round up 55.8 grams. And then this is a 4:2 ratio. And mass of your final product, 159.6 grams. So 1 mole. And I get 28.6. Does that sound correct with you guys? You just type in your yes. Yep, okay, good. And the oxygen, we do the same thing. I'm not going to write out the units. You guys are all right if I don't write all the units out. It just takes too long. So the mass, the molecular weight of oxygen, 1 mole of oxygen is 32 grams. All right, this is a 3:2 ratio, 3 on the bottom, because that's of the oxygen, and then 2 of the iron oxide. And then the mass of iron oxide is 159.6. To 1 mole, and I get 66.5. Does that also confirm with you guys? Okay, so since the 28.6 is smaller than the 66.5, this is the answer for how much iron oxide is formed. So 28.6 grams is our theoretical yield. So that means the iron is the limiting reagent. And then the percent yield is going to be this number, this 26.73 divided by 28.6. Times 100, and I get 93.5%. I'll have to check here. All right, that confirm with everybody? I'll make sure I did my calculations right. Just let me know if that's what you got. I don't hear anything otherwise, so I guess that's right. Okay, so that is where we left off yesterday. That has a little bit of everything in it. It has the doing the mole-to-mole conversions using the balanced equation. It has the limiting reagent part of it, and then it has the percent yield. All right, so pretty much the remainder of the chapter, we still do these stoichiometric problems, but rather than going from grams to grams, we'll have a molarity here instead in liters. Or I'll give you a problem where I give you all of the gas law information and you have to find out how many grams or something like that. But it's basically, it's the same type of problems, we just are doing a little different. So 11.5 basically is gases in a chemical reaction. In this case, you are predicting the volume. So it's using the combination of stoichiometry and the ideal gas law. So you can calculate the volume of gas involved in the chemical equation. Remember, everything is always moles. That's the key. Get everything to moles. That's the trick. Okay? So we first use stoichiometry to determine the number of moles involved and apply the ideal gas law and so forth and so on. Okay, so here is a quick practice problem. Let's just go over this real quick and then we'll kind of do our own. So this just talks about airbags. You know what? Why don't we just do it together? Let's copy it and paste it, and we'll just kind of work on it together, just so you can watch the steps. You guys find it easier to watch me go through it, or just kind of go through the slide and watch it? I think it's better. So I feel it's better like to watch me do it. But what do you guys want to do as we wait for this to come up? Watch you. Okay. Okay, so typical driver side airbag contains 50 grams of sodium azide. All right, so I can obviously get to moles from there. So remember, you always got to get to moles. Determine the volume of nitrogen gas. So this is what I'm looking for. I'm looking for the volume of this. That would be generated by decomposition of 50 grams of sodium azide. So I have 50 grams of sodium azide here. Okay, so 50 grams, I'm trying to figure out how much nitrogen is produced, the volume of nitrogen. All right, so we know that PV equals nRT, so V equals nRT over P. Okay, and this is of nitrogen. So that's what I'm looking for. I'm looking for the volume of nitrogen gas. All right, so R, I know what R is. I know what the temperature is. It's 85. Remember, you have to convert that to Kelvin. So 273 plus 85 is 358. And then our pressure is 1 atmosphere. The only thing is the moles, the N. Well, I'm given the mass of sodium azide. I need the moles of nitrogen. All right, so I'm going to use the balanced equation and the 50 grams and the stoichiometry to figure that out. So you start with 50 grams of sodium azide. All right, and then I find the mass of sodium azide, which is, let's see, 23 plus 28 plus 14. I get 65 grams. To 1 mole of NaN3. Then the balanced equation says there are 2 moles of NaN3 for every 3 moles of nitrogen. Now, I just need the moles of nitrogen. I don't have to find the grams, so I don't have to now multiply this by the mass of nitrogen, because I don't want the mass of nitrogen. I want the moles of nitrogen. So make sure you know where you have to stop in these problems. Just because in all the other problems that we go with the grams doesn't mean that we need that in this case. In this case, I need my final answer to be in moles of nitrogen. All right, so this is basically my equation. So 50 times 3 divided by 65 divided by 2. So I get 1.15 moles of nitrogen. So now plug all those numbers into this equation. So V equals 1.15 times 0.0821 times 358, all divided by 1. 5 times 0.0821 times 358, and we get 33.8 liters. All right, makes sense? So I like this problem, especially since the final's coming up. These are really good final type problems because we are incorporating different chapters altogether. So we're incorporating the gas chapter plus the stoichiometry chapter plus the grams per mole chapter. So we're kind of incorporating a lot into it. All right, so any questions? Does that make sense? Go back here. So they kind of show you that. They convert it to moles of NaN3, and then they do the 3:2 ratio to get the 1.15, which is what we did right there. And then they plugged it into the gas law and got 33.9. Okay? Makes sense. All right, gas chemical calculating required volume of gas reactant. We just kind of already did this. This doesn't tell us anything new. Volume. All right, you guys want to do this? Why don't you guys do this one? Oh wait, let me see. Hold on. No, I don't think this is the one I'm going to do. Oh yeah. We can do this. So do you guys remember what STP means? Make sure you guys remember what STP is. STP stands for standard temperature and pressure. That means you are at a pressure of 1 atmosphere. So just to remind you, your pressure is 1 atmosphere and your temperature is 0 degrees Celsius. This is what STP, standard temperature and pressure. That's what STP. So when they say it's at STP, they're kind of telling you this as your pressure and your temperature. Okay? So I want you guys work on that. I'll give you a little bit of time. So I'm going to convert that to grams. So we start with 1,000 grams of Na2O2, sodium peroxide. And let's see, we were trying to find out what's the volume of CO2. We need this. The volume of CO2 to react with that. So it's pretty much exactly like the last problem. Start with your 1,000 grams of Na2O2. And then, let's see, 46, 46, plus 32, 78. 78 grams is to 1 mole. Again, this is the Na2O2. And then it's a 2-to-2 ratio. So I always write it, even though it's basically 1-to-1, but I still do it. So 1.27 moles of CO2. All right. Basically, it's 1,000 divided by 78. Oh, wait a minute. 12.8? Should that be 12.8? Let me do this again. I think I did something wrong. Yeah, I'm sorry. 12. 12 points. Does that sound right? What do you say? I got 12 points. Yeah. I was off by I put 100 rather than 1,000. Okay, so V equals nRT over P. So 12.8, 0.0821, 273 divided by 1 times 0.0821 times 273. Big numbers. 287. Sound right? $287. All right, good. Any questions? You good? These are heat. Let me just check something. Okay. They don't really have it in here. Let's actually do one of these problems. I don't see one of them in here. But I know in class I talked about it. So, let's see if I can find a problem. It's the same type of problem, except we use molarity rather than grams. So let me get one of these problems real quick. Here, this is a good one. Let me just double check. Okay. Sorry, a friend of mine sent me a text. I was chatting with an old graduate school friend last night, and he was telling me about the Tiger King. I haven't watched it, and he was telling me, "Oh, you have to watch it." So last night I kind of did a binge watch and watched like 3 of the episodes. So he's like, "Oh, good. So that now that you watched it, I can send you all of the memes. It'll make sense." Oh, man, that show. I don't know if you guys have watched it or are watching it, or I'm sure you've heard of it. It's like everywhere. Man, it is. Yeah, I can't believe people like that exist. Very entertaining. Quality, exactly. Quality stuff. Quality trash. Yeah, you haven't watched the Holly. Yeah, it's it definitely is for a certain. Like my wife is like, yeah, that does not entertain me, which is fine. I'm watching it. I'm like, oh my god. Like I don't usually watch shows like that, like the Kardashians and stuff like that. I don't have patience for those shows. That's just stupid. But this is so over the top. It's well, and it's also about a part of our society that I don't think people even know about, which is also why it makes it interesting just to know about tigers and how they breed and raise tigers. And it's just kind of interesting. Okay, so here we go. How many grams of lead chloride is formed if, not is, if 10 liters of a 1.52 molar solution of sodium chloride. Oh, this is a, hold on. Well, yeah, I'll just. It's used. Yeah, that's fine. How many grams of lead chloride is formed if 10, hold on one second, make sure I have the correct. Yeah, okay. Let me give you a few problems. What do you guys start on that one? No Kardashians, yeah. That's. I don't have patience for that. Hold on one second. I think you need I don't have a balanced equation here. You probably need a balanced equation for it. Yes, you do. And there you go. Done. I'm not hearing much from the other people. Travis and Michael. I know you guys are there. Okay. So, here we go. Okay, so remember, I always get in the moles. So, how many grams of this? That's what I'm looking for. Grams of that. And I'm starting with 10 liters of a 1.52 molar solution. All right, so remember, molarity is moles per liter. All right, so you're starting with 10 liters. This is of your sodium chloride. And you have 1.52 moles of your sodium chloride per 1 liter of sodium chloride. So that cancels. So your moles of sodium chloride, you got to get to moles of lead. So 2 moles of sodium chloride is to 1 mole of lead chloride. And that's what I want. I want to get moles. And then I'm going to multiply it by the molecular weight of lead chloride, which I have not done. So let me look at it real quick. Lead is... lead is 207.2 plus 71. Or is it Cl3? Cl2. So I get 278.2 grams. Just one more. All right. So that's a big number. I get 2.114 times 10 to the 3 grams. That sound right? Do you guys get? I got 4, so I guess 3 6 so 2.11 times 10 to the 3. Grams. I did that way. Would you say, Holly? I did that way wrong. Which way did you do wrong? Can we do another one of those? Yeah, we could do another one. But I'm just curious as to what. If you want to go off the mic and tell me, if possible, so I can understand what you mean. Like the whole problem, or?
I did the start. I forgot the whole molarity is moles over lead thing. So I was doing how we find molarity is the moles of solute over liters, and I kind of rearranged that equation.
Okay. Okay. Yeah. We can do another one. Let me see. Okay. Yeah, I understand what you're saying. That's how you did it too, Kayla. Okay. All right. Let me see. Let me. I'm gonna stop sharing. Let's see if I can find a problem here. Let's do. Let's see if I can find a problem online real quick. Oh, actually, you know what? I think I have. Hold on a second. I think I have. I have a practice problem on our. Let me check our problem sheets. I think I have a few of these there. We'll start working on those since we have those already. Let's see, the sheets. This is chapter 11. I think I have a few of these. Let's see. What did I do? If combined. Yeah, here we go. Let's do this one. Oh, this is a good one. Here we go. All right, let's get this. Let me copy this. I'll just copy this whole problem. Okay. Let me share. Can't see anything. Okay, you see that all right? So here's so I give you the balanced equation, calcium hydroxide. So how many liters of HCl would be required to react completely with 5 grams of calcium hydroxide? And then I believe I have a limiting reagent problem here on number 7, which then says if combined 15 grams of calcium hydroxide with 75 milliliters of a 5 molar solution of HCl, how many grams of calcium chloride is formed? So why don't we do these 3 problems? When I give you guys time to work on those. Okay, so notice in 7 it's a mixture of both of them. It's a grams problem and a molarity problem. So you kind of have 2 things that are going on. Okay, the same thing over here. How many liters of this am I going to need? Okay, and remember molarity is moles per liter. So if you want to find moles, remember we also have to find moles, you're going to have to find a volume for it. In this case, I want to find liters of it. So remember, that's moles per liter. I have to have the liter on top of the equation in order to get the answer. That makes sense? I'll let you guys work on it a little bit to see if you guys can get it. Get the chat up again. Okay. All right, I'll give you some time. Which it looks like we need practice on that. Okay, so the first one, how many liters of HCl? So I'm looking for the volume. I'm looking for volume of HCl. Okay, now remember molarity, so this means 0.100 moles of HCl over liters of HCl. Okay, to completely react with 5 grams of calcium hydroxide. All right, so I'm going to start with the 5 grams of calcium hydroxide because I know how to get this into moles. If I look at these two numbers, only the 5 grams of calcium hydroxide is the only thing I have enough information in order to convert to moles. I don't have enough information in order to convert this into moles because I don't know how many liters of it I have. Right? If I have 1 liter, I have 0.1 moles. If I have 10 liters, I have 1 mole, but I don't know how much of it because I'm trying to find that many liters. However, 5 grams of calcium hydroxide, I have enough information there in order to convert that into moles. So you always want to look at what information do you have that is enough information in order to convert it into moles. So, 1 mole of calcium hydroxide. Let me just look it up instead of calculating every time because probably a lot quicker for me to look it up than to actually calculate it. 70.1. 74.1. Does that sound right? So this gets me into moles of calcium hydroxide, and I have to get to moles of hydrochloric acid. So 1 mole of calcium hydroxide is to 2 moles of HCl. So I am now in moles of HCl, which is what I want to get to because that's what I'm trying to get to is HCl. And now I have this. So look at this as a conversion factor, right? It's technically a conversion factor. I have a unit on top of another unit. So if I were to multiply this now by this molarity, but upside down, so put 0.100 moles of HCl on the bottom, and then the 1 liter on top. So that moles cancels with moles, and look what I'm left with. Liters of HCl, which is what I want as my final answer. So that's kind of how I use the molarity. Use it as an equivalent is like grams per mole, right? Like you all know how to use grams per mole. You can either put G over moles, right? The gram over mole, or you can put the mole over the gram. It doesn't matter how you use it as long as the correct unit cancels out. We'll do the same thing with a molarity. So anytime that you see large M, think of it as a conversion factor. So like down here, I have a molarity, and I have 75 milliliters. Well, I can figure out how many moles of that I have, because I can convert this to liters, and it's going to cancel out with the liters on the bottom and the moles per liter, and I can figure out how many moles of the calcium hydroxide I have in this case. Okay? So that's kind of how you handle these molarities. It's not any different, but rather than grams per moles, it's moles per liter. So, divided by 0.1. So you should get, looks like 1.35 liters of HCl. Does that make sense? Okay, good. Did you guys do 7, or knowing that, do you want to go back and do 7? Or do you want me just to do it? What do you guys want to do? Go back and do it. Okay, so I'll give you guys a little bit of time in order to go back and do it. go on pause. Wait, let's do it. Maybe you need some more coffee or something. Tea. Okay, so this is a limiting reagent problem. Because it's saying you have 15 grams of calcium hydroxide, so you have 15 grams of this, and you're reacting it with 75 milliliters of 0.5 molar solution of this, and they want to know how many grams of this you'll be able to make. So this is a limiting reagent. So you got to take the 15 grams of calcium hydroxide to the calcium chloride. That's exactly how we've seen. So this problem is like a mixture of doing a grams to grams and then also doing a molarity to grams. So you're kind of doing both of them. Okay, so 15 grams. So I'm not going to write the units anymore just because I don't have a lot of room here. So 1 mole of the calcium hydroxide is 74.1. And then it's a 1-to-1 conversion. 1 mole of calcium hydroxide to 1 mole of calcium chloride. So that was pretty straightforward. And then your calcium chloride is 71, because there's 2 in them. And then you're adding it to calcium, which is 40.1. So 111.1 to 1 mole. So this will give you how many grams. You guys okay that I'm not writing the units? I want to make sure. I mean, we've done this so many times, and I think you guys are pretty straight. I think you guys pretty much have a good handle on it. Okay, good. So 22.5. What's the 111? That's the molecular weight of calcium chloride. This is grams of calcium chloride. Moles of calcium chloride. It's this thing. Because our problem is saying if I start with 15 grams of this, how much of this will it produce? If I start with the 75 mils, how much of this am I going to produce? Right, the calcium chloride. Did I do it right, or did you guys get something different? 40 plus 71, yeah, 111.1. What I get. That's what I got. Okay. Okay, and then we're going to do the same thing, but the HCl, we're going to start with 75 milliliters and convert it to liters, though. Because remember, your molarity is in liters, so you got to make sure that if you're given milliliters, you convert it to liters. And then 0.500 moles over 1 liter. So remember, moles is on top, liters on the bottom, so liter you can cancel out. So this converts to moles of HCl. But I got to get to calcium chloride. So there's 2 moles of HCl to 1 mole of calcium chloride. And then now, again, we're going to multiply this by the 111.1 grams. .08. What do you guys get? It's so much smaller than the one above. Actually, I got that right. Oh, good. Good. Did you get the 2.08 too? They seem like those are such drastic differences, but it looks like 1, 2, 3 times 0.5.
I did it a little bit different, Steve.
Okay.
But I got the same answer as you.
All
What
right.
I did was, I set up the 0.500 equals x over 0.075, and then I solved for it, and then I substituted
Oh, yeah, you can do that too. So that's just using the equation. You were just using the m equals moles over v. Is that right? Yeah. So
and I solved for it, and then I put it in the...
Yes, so you did that, and you solved for the moles, right? So m times v, right? Which is exactly what this is. Here's my v, and I'm multiplying it by my m, right? So what you're doing is, rather than having it as one full equation, you're doing this separate, which is what this is down here, and then you're getting that answer, and then you're continuing on with the rest of it.
Yeah, well, it worked, I guess, so that's good.
Oh, yeah. I mean, it's the exact same thing. It's just, rather than doing it as one long equation, you're just breaking it. You're breaking it up in equations. Yep, but it should work.
Beautiful. Thanks.
Okay. Yep. No problem. Yep. So you're. So I guess let's see how many grams of calcium fluoride. So the answer should be 2.08. And then the limiting reagent obviously is the hydrochloric acid, since that's what these numbers are coming from. So so problem 7, the answer is HCl. Okay. All right. Good, Kayla. Holly, you got it. And makes sense, Holly?
Yeah, I got it. I just miscalculated the calcium chloride. I only did one chlorine,
one chlorine.
instead of 2.
Okay.
And so that kind of gave me 75 as opposed to 110. But I did the same way that Kayla did, actually. I did
that's totally fine.
Converting it into the grams or whatever first and then doing it.
Okay. All right. Yep. That's no problem. And Michael, Travis, are you guys there? They're signed on, but I don't know if they're there. Oh, Michael, hey, what's up, buddy? All right, so everything's good for you then, Michael? Got everything? Okay. Yeah, ready. Okay. Okay. All right. Well, that's pretty much the whole chapter. If you guys have any other questions, I can go over those. Otherwise, tomorrow we're going to do a review for the exam on chapters 8, 9, and 10. But I think doing this is good because it definitely helps you. I didn't finish chapter 11. There's the heat one, but I can save that until next Tuesday. We can kind of go over that. All right. But otherwise, if you guys don't have any other questions, that's all I have for today. You guys good?
I did have a question. So we decided that the test was open. Is it tomorrow, Thursday, or is it Friday?
Yeah, I'll probably open it tomorrow. I haven't made it yet. It just all depends if I'm able to make it this evening or if I have to make it like tomorrow. But either way, I think I'm giving you guys till like